we have one other type of loop in MATLAB, and that is the while loop. The for loop that we have seen up until now is basically a derivative of a while loop. But the for variation of a loop is more frequently used than a while loop. That's why we have it as a separate loop. The for loop that we know runs a specified number of times. We're telling it, hey for loop, please do this calculation 10 times for these 10 values, and it does it 10 times. The while loop is a bit different. The while loop runs until a given condition is no longer true, which means that the while loop is useful when you don't know how many times your loop should execute. Let's say that we want to generate random numbers, and we want to keep doing so until we get the number 50. So we can create a while loop that will do this for us. So while, open brackets, and here give it a condition. The condition is while the number is different from 50, and inside the while loop we're going to generate a random number. So number equals round I from 40 to 60, 1, 1. So we are generating one random number. And finally an end. Now, the condition here checks if the number is different from 50. So if we generate the number 49, 49 is different from 50, and this will return a true result. While this condition is true, this piece of code will be executed again and again and again. If we run it, as you can see, we get many different numbers, and finally at some point we got the number 50 and the loop stopped executing. We can add the counter variable inside this loop, and we can make it increment by 1 after each iteration, and that way we will see how many iterations actually it took to generate this number. So counter equals to counter plus 1. And let's run this. And as you can see, the number 50 was generated at the 32nd iteration. If we rerun it again, we get it on the 10th iteration. If we run it again, 7th iteration, 81 iterations. So this is the difference between the for loops. If we do something like this with the for loop, we have to say run this loop 50 times, and we may never actually get to the point where we generate the number 50. This is the difference with the while loops. Here we keep generating numbers in this particular example until we finally find the number that we are looking for. You will find yourselves using the while loop when you encounter more real-world scenarios. For example, and I will not go into the specific details as to how exactly to do this, if you have a sensor, some kind of sensor hooked up to your computer, and you're reading data from that sensor. Well, since you don't know how much data you want or how much data will be actually acquired, you will use your while loop, make it acquire data until you reach your threshold, which is unknown at the start of the data acquiring process. Or maybe you can make it run until you hit a button on the keyboard. The loop will continue until you intervene, and again, unknown number of iterations. We can also use it in calculations. So let's take our motion of a point again. If we don't calculate our roots, we don't know when the point will hit y equals 0 again. So when it starts dropping down, we don't know when it will hit the ground. It will also be dependent on how many points we're going to calculate, which can also vary. So we can pre-calculate all of the points, including those that will go below y equals 0. And we will use the while loop to plot only those that are above the 0. Here I have already prepared the code, and I have all of these values already calculated. So our while loop will have a condition, and that condition is whether we have reached y equals 0 or not. So we are going to create a new variable called reached y0, and we're going to set it equal to false. We're going to pass it to the while loop, and we are going to say while reached y0, and this is the loop, but since this is false, this loop will never run. So we're going to invert it. So you can read this as while we have not yet reached the 0, execute the code in the while loop. And we start plotting each of the x and y values. This is a very common practice to have a single boolean variable as a condition and have a condition within your while loop that will reverse its value. The condition within our while loop that will reverse the value will be if the y gets closer to 0. So if y is less than 0.1, we will set reached y0 to true, and that will terminate the while loop. When we set this equal to true, and when it comes back to the while loop to recheck the condition, true negated will give a false, and that will interrupt the loop. Now here we have something that is missing, and that is an iterator that will take each of the points from our x and y's. So we are going to create it. So we're going to create it. I equals 1. And for each iteration of the while loop, we will increment the I by 1. So I equals I plus 1. Now, where are we going to use this I? First, we are going to use it in the check of the y, in the check of the current y value. The current y value is y of the index. And we are also going to use it while we are plotting. So I'm going to say plot of x of I, y of I. We are going to plot a circle in red, and yeah, let's leave it like that. And let's run it. Okay, the problem here is that we are not holding the plot, so let's create a dummy plot, so plot of 0 and 0, hold on, let's run it again, and there we have it. We have all of the plot, all of the points. As you can see, here we start from the 0, but here we're not quite actually reaching the 0 itself. We're close enough, but we're not at the 0. Since the nature of our calculations is discrete, we may never actually hit the exact 0. So that is why instead of checking whether y of I is equal to 0, we are checking whether it's less than 0.1, and this is close enough for our case. Since this code will not plot the final point when we detect that we are moving below the y, it's not going to re-execute the plot. We're going to add another plot here, x of y, y of I. So this will be the, let's make it green. This will be the plot that will plot the final point. So if we run it, as you can see, the final circle here at the 0 is in green. Now, you can see here that we have way more x and y values than we have actually plotted. We have plotted 409 values since I reached 409, but we have way more x and y's, and we know that because if we plot x and y, we get a lot lower than the 0, we get at -8. And we can get rid of all of these values that we don't need. Right after our while loop, we're going to say x of I plus 1, so the iterations plus 1, because we have one final point here that is not addressed in the iterations, until the end of that vector, set everything equal to nothing. And the same thing for the y. If we rerun this now, you can see that both I is equal to 409, and now the vectors are also have a length of 409. And we can use this and create one additional plot for x and y as a line. So make it blue, line width of 2, grid on, grid minor. Let's run it. And you can see that we have each of the individual points plotted until we reach 0 again. Here the green dot down here. And we also have a blue line that shows the path right on top of our markers. This is a nice example where we used the while loop to plot what we wanted until we reached a certain value. If I now change something in this code, if I change our number of points and we run it again, as you can see, we get a lot less points, but since it's not as accurate now, we have a lot of space between the points. You can see that we dropped a bit below the 0, but still we ended up here. This is where we ended. If we don't have the condition that interrupts our while loop, we will go a lot lower than this. Similarly, whatever we change now in our initial conditions, the while loop will always find a way to create the plot from 0 to 0.